Just to move on to the next talk, moving from downtime minute and budgets, looking at how SoundCloud deal with their microservices architecture. They spoke a little bit about it last year, about how they were moving more into the microservice sphere. And along with the theme of this session, we're now looking at the availability objectives of their services. So they drill down through all of their services to look at basically what they were available and reflect that back up. So we're going to hear Bora talk a little bit about that now for the next 20 minutes.
Hi everyone, welcome. First of all, for the people who don't know SoundCloud is the largest online audio distribution platform. My name is Bora. I'm a backend developer at SoundCloud. I have been there for about 3 years. The printer schedules claims that I work at Yahoo. That is not correct to best of my knowledge. At the moment I'm part of core engineering, and in core engineering we are tackling the engineering concerns that are cross-cutting and not tied to specific business features. So SoundCloud does microservices. We adopted this architecture around the year of 2013, and since that time the number of microservices we have on production has been increasing. At the moment we have 140 services, and coincidentally we have 140 engineers. The main concern is that how do we improve our availability in a microservices architecture? So let's have a look at how our users access our platform. Our backend services, they live in our data center, and those backend services, they have public interfaces. Those are our APIs, and they power our client applications, which eventually serves the needs of our happy users. Unfortunately, time to time we get outages on those APIs. A typical outage for SoundCloud looks like this. We have a use case on our API, and in this use case we depend on some of our microservices, and one of them starts misbehaving. And this misbehavior bubbles up to its clients, eventually reaches to the API level and breaks the user experience. So until recently, like if you are lucky, we catch this kind of outages on our side via automated alerts. If not, our users let us know in polite words. And until recently, we were relying on post-mortem meetings primarily on taking measurements for the future outages. So what we were doing was writing a post-mortem after each outage and going through them at the end of the month and look for the common patterns. In other words, we were trying to find out those risky services that has caused multiple outages before and is likely to cause another problem in the future unless we do something about it. Post-mortem meetings have helped us a lot actually to improve our availability. However, we want to be more proactive, and we want to detect those risky services earlier before they cause an outage. So with that purpose in mind, we adopted serviceable objectives. The idea is about defining an availability objective for each of our microservices. And availability objective is the minimum availability that we can afford to have for a given microservice. So we continue to check the availabilities of our microservices, and if the availability of a service drops below its objective, then this is a red flag. We need to do something about it, or it will most likely cause an outage in the near future. Implementing this idea has two steps for us. First, we need the infrastructure to calculate, track, store historical availabilities and display them. And the second phase was going through all of our microservices and analyzing their use cases and come up with meaningful availability objectives for them. Let's look at the infrastructure that we have built. First of all, we need to come up with an availability definition that can be objectively applied to all of our microservices. That definition for us has two criteria. Those are error rate threshold and the latency threshold. As long as a service is performing within those boundaries, we assume this service to be up and available. One detail here is that we look at the 99th percentile of the latency when we are assessing the performance of a service. And SLO is defined with 3 parameters. First two are the thresholds, and the last one is the minimum availability that we can afford in the service. In order to calculate the availability, we are using 3 key metrics. Those are the number of total transactions, slow transactions, and failed transactions. And the formula that we use looks like this. It basically has 2 conditions, and these 2 conditions has to be satisfied in order to consider this service as up and available. In the first one, first of all, we calculate the availability over a given time, and within this given time, we are looking at how many transactions we had and how many of them are failed. And we are comparing this ratio to the error rate threshold we have. And on the second condition, we are checking how many of the transactions were slow, and we are checking if it is less than 1% of total transactions. We are using 1% because we are working with the 99 percentile of the latency. Let's have a look at the overview of the infrastructure we have. So we have microservices. They get a request and return a response. What we provide is an SLO wrapper for our microservices. They sit between the client and the server, and they intercept all the incoming requests and outgoing responses. They analyze this input and output, and from this analysis, they are able to figure out the correct numbers for the SLO metrics. Those metrics are then fetched by Prometheus. Prometheus is our monitoring system. And Prometheus is able to calculate the availabilities given those metrics are available. We don't store the historical data on Prometheus. For that, we built the last item. We built the last item on the chain. That is a tool that we call services directory. Services directory fetches the availabilities of our services from Prometheus regularly. It tracks the historical data, and it also has a UI, and it tells us it lists all of our microservices, tells their availabilities, and most importantly, it indicates which ones are below their availability objectives, which is really useful information for us that guides our engineering decisions. Let's look at how we analyze the use cases of our microservices. This is how our client applications use our platform. The APIs we have, they are responsible for fetching data from our microservices. This is how our microservices organization look like. We have two main layers. At the very top, we have the edge layer, where our APIs live. At the very bottom, we have the data layer. And the services on this layer, they are responsible for providing data. They don't contain any business logic. They just give the data for the business entities that they represent. The examples are tracks, users, playlists, and so on. As said, they don't contain any business logic because all the business logic is implemented on the service in the middle, value-added layer. The services here, they perform the business operations, and they basically use the services on the data layer to perform their operations. The couple of examples of request flow looks like this. The key point in terms of availability in this architecture is that the services on the service value-added layer, they serve a single purpose, meaning they power only a single feature. Whereas the service on the data layer, they power multiple features. That means if you lose a service on the data layer, that means we are losing multiple features in our platform. And if you have an outage on the value-added layer, this is most likely losing a single outage. So the outages on the data layer is more severe than the outages on the value-added layer. And because of that, the SLO objectives of the services on the data layer, they are stricter than the SLO objectives we have on the value-added layer, which means they have lower error rate, lower latency threshold, and higher availability target. Another thing that we look at when coming up with the meaningful availability objectives is graceful degradation. On the right side, you can see the likes module we use on our website. This likes module shows the last couple of like tracks of a user. It shows the track data and the statistical data. And apparently it uses the track service and the stat service. In the cases where we have an outage on the stat service, what we do is to gracefully degrade this user experience. We are doing this by hiding the statistical data. And because we can gracefully handle this outage, while we expect a high availability from track service, we don't expect such a high availability from stat service. So the main questions that we ask ourselves while doing this investigation to come up with the correct availability objectives are those. Where does this service stand in our architecture? How many clients does it have? What are the demands of the clients? How many use cases does it power? What would be the impact on user experience if you have an outage on this service? And is there a way that we can gracefully handle the outages that we may have on this service? Lastly, I will talk about the key learnings that we had so far with the service level objectives. First of all, without the formal process, identifying risky services is hard. We have some services, like some of our services perform up to their expectations and some of them don't. And when we had fewer microservices, it was easy to know which microservice to work on first. But as we write more and more microservices, it became harder to know which microservice should be worked on first, which could do the most impact on the overall availability. And we quickly realized that we need a formal process and tooling to support our engineering decisions on this. And the second thing is that don't over-engineer your services. As we fail to correctly identify the risky services, we end up working on services, and these efforts did not really contribute to the user experience, or it did not increase our overall availability. If a service is already performing above its availability objective, there's really no point in improving it further. And SoundCloud is still a relatively small engineering organization. At this stage, we just cannot afford to spend engineering time on the things that do not improve the user experience. So lastly is that it ties back to the first item. Let the data guide your engineering decisions. Before we adopted service level objectives, the decisions that we took during the post-mortem meetings were based on the feelings and the opinions of the individuals who happened to be at the meeting. However, with the adoption of service level objectives, we are now able to make informed decisions, and we can base our decisions on the data that we gather from the service level objectives, and this makes SoundCloud a more efficient engineering organization. So those have been our key learnings so far, and thank you very much for listening. Yeah, we have time for questions if you have any. Yes, please.
I was wondering what do you consider as a slow request?
A slow request. Yeah, the question is, what is a slow request? Slow request for us is, we define the latency threshold for all of our microservices. And a slow request is a request that is served above that threshold. So if the response time takes longer than threshold, we mark that as a slow request, and it goes to our calculation.
I have a quick question.
Yes, please.
You mentioned the user experience. So
yes.
That shows, I suppose, a lot of feedback. How do you work with the UX team and the product owners? Have they a lot of feedback into the operations and site reliability too?
Yeah, that's a good question. Actually, this is the part where we are trying to improve a lot, and it is not so easy to include the UX team into availability decisions. This is an ongoing process, actually. We don't have a clear solution on that yet at the moment. And what we are trying to do is we do user testing on site, and all the regular things that other companies do as well. And we try to talk with the teams, and we are trying to integrate feature teams as much as possible to our projects that we are doing in the core engineering. And feature teams have their product manager, have their designers, and they are fully functional teams. So we are trying to listen to them and trying to integrate them. But as said, we still don't have a clear solution for that yet.
Any last questions?
Yes, please.
How decide the SLOs per microservice?
Yeah, of course. So who is deciding the SLOs for our microservices and how? Okay, so the decision belongs to the owner team. So we have our feature teams, and they own their microservices, and they should come up with the right availability objectives. And how is looking at the use cases. So, like as said, first of all, what would the impact be on user experience if we have an outage on this service? And then, what are the clients of this service there? How many clients are there? And what are the demands of clients? And what kind of features are they supporting? So if, like, we list our features based on their severity. Like, for example, stream, or for playback and monetization. This kind of features are the the most important features. And if this microservice is involved in supporting any of those features, then their availability objectives should go higher. So those are, I mean, this is still an informal process. There is no like written guidelines how to do that. But these are the, and actually this project is still being propagated throughout other teams, and we are still trying to find ourselves how to do that best. But these are the ideas for now.
Thanks very much, Bora.
Thank you very much.